Yes, yes,
Yeah.
please.
All right, so that as you can see on the screen means data analysis expression. And if you're familiar with Excel function, um, you won't have problem understanding this. Like I mentioned earlier, DAX is more advanced, and the whole essence is it adds more to your data. You're able to do more, um, um, but you're able to get more out of your data. So possibly you've seen in Power Query when we're doing some transformations, we're able to add columns. Let's say you didn't have a column that speaks to profits, or just using that as an example, or any column at all that you think would add additional value to your existing data. Um, I'm sure we saw how some of those things were achieved in Power Query. All right. So in the same way, when we are using DAX, we can use DAX to basically for two things, right? For your calculated columns, all right? You can use that for our calculated column and calculated measures. All right. So when we talk about columns, um, just like you already know, let's say you want to add an extra column to Um, so looking at this data, this is our sales data. I'm working with the electronic sales data. I'm sure we're already familiar with it. Now looking at this data, we have um, unit cost, unit price, and other quantity. Right. So, but what if we wanted to measure our total sales, right? And possibly our total profit as well. We don't have that existing. So what we are saying is we can use DAX to create those extra columns. And once I create an extra column, you are able to see the result immediately, right? Just like you see in any other table, we demonstrate all of this. And again, what we can do with extra calculated columns, we can also replicate in measures as well. And I would also explain, give give us some of the differences between a calculated measure and a column, and why it is better in terms of performance and analysis to go with calculated measures, right? So when we talk about measures, I've talked about columns, just you adding an extra column. So in Excel, if you wanted to multiply these two unit price and your quantity, you probably get your total sales, right? You do a in the other column, put up a function that multiplies these two figures, right? That is what we're going to do with calculated column. All right. So I think before I go on into or diving into the functions and all of that, I think it's also important that I talk about some of the differences between calculated column and calculated measures. All right. So like I pointed out now, the result of the calculated column, you are able to see it immediately on your table. I'll do an example to explain what I mean here. So I'm already in Power BI desktop. I've loaded data into the data model. And if I have to go to my view here, all right, let's say we want to add a column that speaks to the total sales. Um, Total sales is unit price times order quantity, right? Hope I'm not missing out anything, right? So if I want to add an extra column to this to give me that, and recall that what we are trying to do here, we can actually do it in Power Query, right? But now we are talking about DAX and how DAX can help us add more to our data. All right. So in this tab, you see all of these options right here. All right. But what I'm interested in is this, the new column. All right. So once I click on the new column, I see this formula. So I see this come up. right? So this is what allows me to, you know, express myself, write whatever function I want to write. So in this scenario, we want to create an extra column that speaks to the total price, right? I'm just going to expand this. So I'll say total sales. So before I proceed, I don't know if there are any questions so far. If there are, please just raise your hand and ask, or just ask. So in the formula bar, you see this right here. We have this left part is where you would have to include the name of your table, or rather the name of your column. In this case, we are going to call it the total sales, right? And if we want to do total sales based on the data we have here, that's the unit price and quantity. So I'm just going to start typing unit price and see what happens. So as I'm typing unit price, we have this thing called IntelliSense. It's Microsoft IntelliSense. So it helps you. It looks through your data model and tries to make sense of what you're typing and gives you options, right? So from here, recall I'm looking for a column unit price, right? So from here, I'm already seeing something relating to unit price. And how it writes it is, it first gives you the table name, which is sales details, right? Which is what we have here. This is the table name. And then you have a square bracket and then the name of the column. All right, that's how you're able to identify that. So I have my unit price. So just like your regular mathematical, the way you write your normal, do your normal calculation in math, I just do this times this. This is as basic as anything. So I'll type order quantity here. As I type order, I'm able to see this just the same way for the other one. And then once I'm okay, I click on OK here. Right? And then here we can see that he adds the column here total sales. So what it did was to multiply this and this to give me this. And then it applies it same thing all through the rows I have here. All right. Now let me go back to view because I want to show us the difference between the measure and a column. Remember, we're trying to look at the difference, right? So I'm just going to call up a visual, and this is a table, right? This is a table right here. That's what I'm using. And in this table, let's say I'm going to call up, so you've done modeling, right? So I've already done the modeling. I've connected all the tables here. All right, so I'm able to use that here. So let me say I want to see, let's say by states, right? So let me bring in my states. How many states do we have here? Okay. And then this is the calculated column that I just did now. This is it, total sales. I'm going to bring it in. Okay. So this is total sales that we have calculated with, this is a calculated column done with DAX, right? That we just saw now. And then it gives me this. Now I'm going to do the same calculation using a measure. All right. And from there, I'm able to tell you the difference. Now, if I want to create a new measure, right? Even from this tab, I think there's from here, from the home tab, I can see this. This is what I'm looking for. All right. So I have new measure, I have quick measure. I'll come to this quick measure later on, but what I want to use now is the new measure. So new measure, once you click on it, that allows you to write your own DAX formula or DAX expression. Right. Now, So because we're adding an extra column to a table, right? And I want to, what's it called now? I want to multiply these two, right? I'm going to use a function. So as I'm doing some of this, as I'm using the functions, you find out that it's something you used maybe before in Excel, but if you entirely need to it, there's no problem at all. So I'm going to use this is total sales. This is the name of the measure. Total sales, sorry. Total sales. Let me name it 2, right? So here I'm going to use so because I'm not dealing with, well, I should have started with the single functions, right? But because I'm not, I'm looking at adding extra column to a table, right? So I'm going to use the sumx. So sumx, whenever you see, of course, if you just go to sum just sums up the values you have in a particular column. But by the time you introduce the x function, this is more or less like a table function, right? And once I click on the open bracket, you would observe something like this, right? This gives you an idea of what the parameters in that function should be. So it tells me that sumx only allows 2 functions. Now, some other function, 2 parameters rather. Sumx as a function allows only 2 parameters, which is the table, and then an expression. We'll see what that means. Some other functions allow you to have more than 2 parameters. Some are required parameters, while some are not. They are just optional. But in this case, the 2 of them are required. So here, I would have to name a table here. So since we are dealing with the, we are trying to multiply the other quantity and what's the name of the other column now? And the we're trying to multiply unit price. Yeah, unit price and other quantity, right? So, but they are in the sales order details table. So I would have to reference this table first, which is the first argument here or parameter. So as I type, it gives me, you can see that IntelliSense has popped up again. So as I was typing SA, it pops up all of these, right? All these functions. But what I'm actually looking for is this table. And you can tell it's a table because of this tiny icon here, like a table. Once you see an fx in front of the name, you know it's a function. But what we're looking for here is a table. And this is what we're looking for, right? So now that I've gotten my sales table, next thing is to put a comma, right? And now it's asking me what is my expression. Now, the same expression that we did when we were creating the calculated column, I'm going to bring it here. My expression is simply my unit price times my what now? Other quantity. Other quantity. And I'll close the bracket, right? And okay. All right. So it has added, right? So I've created the measure. And if you check here, you see that what we created now is the total sales too. And you can see is sitting under the channels table, right? But if I go to my table view here, this is channels table. Quite all right, I can see that there are 3 items here. So I'm seeing channel key, which is this, right? I'm seeing channel name, which is this, right? Then I'm seeing what I just created now, which is the totals, the total. It's not shown here because it doesn't add to your table. It just just call it just a virtual figure up somewhere, waiting for you to use it. So what we have just created now, I'm going to drag it into this visual. Just going to be the same thing, anyways. Voila. So you can see that one, they are giving me the same thing. Check out the figures. The same figure. Check for ABIA. This is the calculated column. This is the calculated measure. The same thing, right?
But Emmanuel, can you do a focus so they can see because it's so tiny?
Okay, hope it's better now.
Yeah.
All right. Okay, so we can see that it's the same value. The only difference is that we use calculated columns for one, and we use calculated measures or just call it measures for the other. And herein lies one of the difference of the calculated measure and column. So for calculated column, we're able to see the results in the table. We are able to view it here, total sales, right? And for calculated measure, we don't see it. It's just sitting somewhere waiting for you to use it. All right. Any question on that? Any question on that? All right. So I'll move on. All right.
Okay. So, 1 minute. Okay. Remember yesterday in Power Query, we also calculated total sales, total costs, and the profits. So what this is DAX we're working on. Yeah, it's the same calculation, but you can see that we are using DAX now, and it's a formula. So take note of the formula. Yeah, take note of the formula so you don't have to cram anything. Yeah, just take note of the formula that you use for DAX. Okay.
Hello.
Oh, sorry. I've actually been speaking, not knowing that I was muted. Sorry. Can you hear me now? Hello?
Yeah, we
Can
can
I?
hear you. Well, I can hear you.
All right. All right. Sorry. I actually. All right. So we've seen one of the difference, right? So we are going to the second difference between a calculated column.
Emmanuel. Excuse me, Emmanuel.
Yes,
Emmanuel, Kanayo has a question on the chat. He says, please, why are the figure the same in sales and sales too? Okay, it's the same total sales you're calculating, just different methods. Yeah, Kanayo. One was a measure and the other one calculated column. Emmanuel, can you throw more light on that? So, because he was asking why it's the same.
Yes, it's the same because I was trying to explain that you can use calculated column and calculated measures for the same thing, right? But here we are trying to describe the difference between a column, calculated column, and a calculated measure. So the two calculations, we arrive at the same figures here. The difference is that the total sales we have here, we did it with a calculated column, and it is visible on the table. We're able to see it here on this table, right? But a calculated measure does not sit on any table. It's just there for you to use it. It's just think of it like it sits in the thin air, waiting for you to use it. You don't see it visible on any table, even though it's right here. Even though it's right here as total sales, and you can see it's under the channels table. But looking at this channels table, you can only see two columns. You won't see what I did with the calculated measure, but you can see the formula right here. Right. So I was trying to describe one of the difference between a calculated column and a calculated measure. I hope that answers your question. So moving on to the second one. So a calculated column can be used in filters and slicers, but you can't use the same. You can't calculated measures. You can't use it in filters and slicers. What do I mean? Now I'm going to create another column. So I will need help here. I will need help here. Let's say, what do we use now? Let's say total sales, right? And let's look at the figures that we have here. We have the lowest figure is about 4.75, and the highest figure here is about 81,000. Hey, 1,000 plus. So what we are going to do is this, right? Let's create a calculated column that says if the total sales is more than, what do we say now? Okay, let's say if the total sales is more than 50,000, then we can name it high sales, right? If it's below 50,000, okay, if it's below 50,000, it's low sales. Let's just deal with two for now, right? You can actually add more arguments to that to say it's between 30 to 50, and it's medium and all of that. But let's just keep it very simple for now, right? Since this is just introduction, and I'm trying to look at the difference between a calculated column and a calculated measure. And as I'm talking about the difference, I'm already writing DAX for you, so you can take note of the functions, right? So far, we've only been able to just multiply two columns, right? So this next one, I'm going to use another function, which is something we're already familiar with, right? Just like maybe you had this when we created maybe in Power Query where you dealt with conditional column. This is something similar here as well. All right. So let's say I create a calculated column. All right. So I click on new column. So I'm going to what do I call it? So let's say I call it sales status or sales what now? Any help? The sales status. Let's say I call it sales status. So I'm trying to differentiate between my high and low sales. All right. So please, when you're writing your DAX, it doesn't really consider spaces. So I can come down here. I can give as much space as possible. It doesn't affect anything, right? I can still write my code here, right? It doesn't consider spaces, right? It just looks at the arguments and parameters we have. So this is simple logic, right? I'm saying that if is what we're going to be using, right? And then we have these visual in intelligence that will show us the parameters that we need here.
Emmanuel, can you maximize your screen? It's quite tiny. Can you maximize?
I'm not sure how I'm not sure how I'm supposed to do that. Is anybody having that problem? Are you able to see my screen clearly?
No, it's very tiny.
It's quite tiny.
Wow.
I don't, do a full screen. Everyone, Kanayo was saying that it's quite tiny. Kanayo, do a full screen.
Sorry.
Yeah.
Lolade's got a question. She said, hello, Franca. Okay. Please, can you kindly go through DAX in your own words because I'm lost. Thank you.
Hello. Okay. Please, can you kindly go through DAX in your own words because, okay.
So when you say go through DAX, is it what DAX is or definition of DAX? Okay, let me take that
okay,
again. Right?
Yes, okay, can you throw more light? Just since, because she's been, I think it threw her out, the internet threw her out. Yeah, if you can just go through it again to explain. Okay. Yeah.
Okay, so when we talk about DAX, right? DAX. DAX means, or rather, is data analysis expression. So it's just a collection of functions. If you're familiar with Excel functions, right? The basic ones, say the basic aggregate functions, sum, count, average, minimum, max, that you, if you are familiar with Excel functions. So that is just a collection of functions that allows you to add more value to your data, right? So even though they are more like so it that is more like a language, right? That allows you to add more to your existing data, just like we've seen. So in Power BI in general, when I say in general, there are different ways to do the same thing, but then you would have to weigh the pros and cons. In Power Query, right, we handled conditional columns where we're able to create additional columns or even custom columns that allowed you to quickly multiply two tables. So what we are trying to do is achieve the same thing using DAX, right? DAX is just say it's a collection of functions. Let's keep it that simple for now. So what we did earlier, if I don't know if you were able to get what we did earlier. What we did earlier was to use DAX to get our total sales here. This column wasn't existing before at all. It wasn't existing before. And if I click on total sales, right? This is this is this is total sales. Now, how do you know a calculated column? If you notice, it has this thing in front of it, right? That's how you're able to visually identify a calculated column, right? This one, I'm just creating it. There's an error there. That's why you're seeing this triangle, because we haven't completed what we wanted right there. But this is the one we created earlier, right? Sales. And simply what we did was multiply unit price and other quantity.
Sales, other quantity. Okay.
Yeah. So these sales, so if you look at the structure of how we brought out this thing, right? You notice that sales details is the name of the table.
Yeah. Yeah.
And it's the name of the table. So it first gives you the name of the table. So just imagine that you just have unit price, right? And you have a numerous tables you're playing with. You won't be able to identify where the column is coming from. So this is more like a naming convention. All right. So with this, you're able to tell quickly that, okay, unit price in the sales details table. Right. So now we are multiplying two columns in the same table, which is the order price. So this one in the square bracket is the column that we are multiplying. Right. So what we did here was just a simple, we didn't even use a function here. Right. What we did here was just to do multiply unit price and other quantity to get our results here.
All right.
Exactly. Yeah. So do you have an understanding, or do I move on, or do you need extra additional explanations to that?
No, I think I'm okay now.
Okay, good. All right, so we're going back.
Okay, sorry. Let me just say something. Okay, remember, just if you remember what we did yesterday. Yeah?
Yes.
It was just okay, Lola did yesterday we did total sales is equal to unit price times quantity in Power Query, remember?
Yes.
Yeah? Yes. Okay, but here, yeah, in DAX, you refer to you all you're doing is you reference the table name first. Can you see that's the sales detail? Because the column is on this table. So each time you reference the table first. So that's the difference here. Do you understand?
Yes.
Yeah, so you do sales details before the column name. Yeah, that's the difference. Yeah.
Okay.
Okay. All right then. Emmanuel, back to you.
All right. So So recall that we're looking at the second difference between a calculated column and a calculated measure. We said that you can use a calculated column. So let's complete. It's showing me, it's giving me an error here because we didn't complete the formula. So I'll go back to it again. So we're starting, so we are introducing our first function here, right? Which is if, which is similar to the if in Excel as well. So let me try it again. So once I write if and then with this open bracket, I'm able to see, sorry, about that. All right, so I'm able to see this, right? So what we have here, these are the parameters that you can have in an if function. So here we have the logical test. Logical test is simply, if you're saying if, it's more like a writing expression. If this is this, or if this is more than this, or if this is less than this, that's your logical test. Now, if it passes your logical test, what is the result? What do you want the result to return? Right? Otherwise, what will be the result if it's false? We'll explain that. Now, you are seeing that these ones are just separated by commas, and then this one has a square bracket. Earlier on, I mentioned that when you have a function, you can either have the parameters required or optional. Now, from here, you can tell that the first two, logical test and result if true, these are required parameters in this function. But the result is false. You don't necessarily have to put it. You can decide to. It's optional, but your function will still work properly as long as you get these other two right? So our first argument here, or our first parameter, is what is the logical test, which is if the total price is equal to, remember we are looking at two things now. If it's greater than or equal to 50,000, return high sales. Otherwise, return low sales. They just stick to those two arguments for now for simplicity. So I'll go ahead and write if total sales. Sorry. All right. So I'm going to write total sales. So as I'm writing total, just like before, because of this, right? Because of this, and this is the column I'm looking for. Another interesting thing to note here is this. You can see what we created here. You can see the icon is looking like a calculator. That is that measure we created, the total sales tool. So this also helps you to quickly identify, just by me looking at it, which one is a measure, which one is a calculated column, right? So this icon shows you that you're looking at a column in a table, while the calculator tells you this is a measure, right? But in this case, what we are looking for is the column, the total sales column. So we are saying that if total sales is greater than or equal to 50,000, right? That's what we said. This is our logical test. If the total sales is greater than or equal to 50,000, what is the result if true? So I want you to return high sales. Now, because high sales is a text, I would have to enclose it in a double quote like this. So it's a text, and I have to include that in a double quote, right? Now we've completed our second. You can see as I'm moving, it's highlighting where I am in the argument. So I have high sales as the result if true. Now, if this is false, what do you want? Now, result if false. I can decide to close this argument here. And so whatever it sees that the total sales is above 50,000, it returns high sales. And if it doesn't, it's just blank, right? But in this case, I want to use this optional parameter to say if it's not high sales, please indicate it as those sales. Sorry, I have to enclose it in a double quote. All right, and that completes it. And once I click on enter, let's see what happens. So you have this. So you see high sales, high sales, high sales, low sales, low sales, low sales. So you can see that what I've written now has given me an addition. So I'm able to do more analysis with my data. I'm able to run analysis to know how many high sales I had and how many low sales I had, just based on your requirements and all of that. So this is a calculated column. And as usual, it has also been added to our data model or to our table here. And when we say you can use it as a filter, this is what we mean. So I'm back at the visual that we have here. And I'm going to call in another visual called the slicer. This is it here. All right. So I'm going to click on it. All right. And in this filter, I'm going to add what we just created now, which is the calculated column. We want to use it as a filter to filter what is going on here. Right. So for where is it now? This is so I have it as sales status. And as again, how to quickly identify a calculated column. You see this icon, it is too. Right. You see that this is a calculator, so that's a measure. Right. So these are symbols that quickly, tells you what that column contains. So this tells you that it's a date. This means that this column has numerical values and you can sum them up, right? So I'm going to add this total, okay, not total, sorry, the sales status that we just created down into my slicer. And you can see now that I have two things here. So I can click on high sales and then it filters into this. All right. So here it quickly tells me that only 4 states had high sales, and it gives me all of their total sales. So you can ignore these total sales too because it's just the measure. I'm going to remove it, or rather, I'm going to use the measure instead. All right. So I'm able to do an extra analysis. So low sales, there were low sales in more of the states. So we're looking at one of the difference, right? Let's say I do the same calculation with total with measure. So so you see the same formula, right? You see the same formula. I'm going to copy it. So instead of clicking on new column, I'm going to click on new measure. I click on new measure and I create it and say, let's call this sales status 2.
Emmanuel, sorry. Emmanuel, could you copy the format? Yeah. And paste the format, the DAX formula. Yeah. Could you copy that format and place on the charts so they can have it?
Okay.
Yeah. Yeah. Okay. Thanks.
Okay. So let's try this again. So let's say if so here, what is the logical test? If the total sales. So as I'm typing this, you can see that because I'm writing a measure, right? I can only reference the measure. Now watch. Recall that when I was creating a calculated column, I was able to reference another column, that table. Now that I'm able to create a measure, right, using the if statement, I'm not able to do the same thing. But rather, I'm able to reference this measure that I created earlier, which is the total sales, right? I hope it's not confusing, right? So So these are logical tests. If these are total sales is greater than or equal to 2,000, sorry, no comma, then high sales. It's just the same formula. What changes that instead of referencing the total sales in the sales details table, right? I'm referencing the measure, the total sales 2, which is a measure that I created. That's the only difference. But the same thing. And what is the result if false? The low sales. All right. And I click on enter. So as usual, I have it somewhere, right? You can see it here. It's a measure, right? But you can't see it anywhere in a table. And likewise, the same way. Let's say I create another slicer here. So instead of the one I created with the column, let me try and use the one I created with the measure. So are you seeing that I'm not able to use it, right? I'm not able to use it. Recall that we are looking at the differences between calculated column and calculated measure. So the calculated measure allowed me to use my solution as a filter to filter whatever visual I have. But if I do the same calculation on, if I do the same calculation using measure, it doesn't. I won't be able to use it as. I won't be able to use it as a filter. Rather, I can actually view it as a table here. So this is my total sales. Let's see what happens here. I'm going to remove this. Let's see. Okay, that was my total pro. Okay. Okay, I think I have to do this by product, right? But I've just called in my total. I've just called in my, what's it called? Sales, my measure into a table, right? And I'm able to view it, but you're not able to view it or use it as a filter, right? So that is the second difference I've mentioned so far between a calculated column and a calculated measure, right? Any questions so far? Any question? I'm not able to see if anybody is raising their hands or if there's any chats. So please help call my attention to any.
Yes, I'll tell you, let you know.
Okay. All right. So we have looked at two differences now. So the other one, we are not able to, won't be able to, what's it called? Do a test, right? Just like we've seen for this first two. But one thing you should know that when you do a calculated sales, because it's adding to your existing table, it increases the size of your model. So what that means is that if we started this class with maybe the size of this pbix file is say 100 kilobytes, the more calculated columns I add, it increases the size of the file. What that means is that it's increasing the size of your data model, and that is not too good, right, in terms of performance. And so that's why it's always advisable if you can do your calculation using measures, if you can achieve the same thing using measures, it's preferable to use measures to do your calculation. So instead of having these total sales sitting here, there are two ways I can do this. Either I calculate this total sales in the data source. So a data source could be in Excel. So before I even bring it into Power BI, do the calculation in Excel. I'm looking at the performance angle now, right? In case you're dealing with large data sets. if you're connecting to a SQL Server database, it's better you do the calculation of total sales in your scripting. That's your when you write your SQL statements and all. It's better you calculate it there before bringing it to Power BI. Now, if you're unable to do this in the data source, it's also advisable that you do it in Power Query. Do all your transformations, do all your additions, and if you're adding extra columns before actually loading the data into your data model. Now we're dealing with performance issues, right? So that's the third difference between calculated column and calculated measure. You can add as many measures as possible. It doesn't add a single kilobyte to your data model. It remains the same. So calculated columns add and impacts on the performance of your model. So having said that, um, what I'm going to do next is to create a date table. And in creating a date table, we would also encounter some other DAX functions, right, that we can take away this night. So first of all, why do we need a date table? A date table is important because so part of that, right? We talked about. I think I mentioned that we have aggregation functions, right? Okay, this is not moving again. I hope you can still hear me. Okay, so we have aggregation functions.
Yes, Emmanuel can hear you loud and clear.
So we have aggregation functions. So here we have the mean, we have the max, we have the sum, we have the count, we have average, etc. Right? We have all of that. We also have the time intelligence functions, right? So in time intelligence functions, you have things like um, maybe YTD, year to date. You have things like quarter to date. You have things like um, uh, same period last year, right? So you don't have to take note of these things. I'm just trying to give you the different categories of DAX, right? Now, what I'm about to do in creating the date table, reason why we create a date table is so that the time intelligence functions that Microsoft has made available through that, right, would be able to function properly. And so because time intelligence functions, it requires that your data is continuous, your date is continuous, right? So what that means is that, for example, you own a shop, you make sales, you only open from Mondays to Friday. So you make sales Monday, Tuesday, Wednesday, Thursday, Friday. But then over the weekend, there's no sales until the next Monday. So if we're counting, say 1, 2, 3, 4, 5, that is continuous. But because you do not work on a weekend, we have 6 and 7 missing. And so we now have 8 coming up next. So we see 1, 2, 3, 4, 5, first day, second day, third day, fourth day, fifth day, and then go to 8, right? That is not continuous. And then the time intelligence functions would not behave properly if you do not have a continuous data, right? So this is the reason why we would always advise that if you have to do anything relating to time intelligence analysis, it's better you create a date table because date table ensures that your dates are continuous. So even if there's no activity on that day, say on a weekend, it still records 6 and 7, but then it assigns no value because no activity was recorded in that period. Hope that is making sense. So that is the reason why we're going to create a date table. I think by the time I'm done creating the date table, we would have questions and you probably want to get your hands on it. Hello?
Manuel.
Hello? Can you hear
Okay,
me?
you're back.
Yeah, sorry, where did you lose? Where did you lose me?
Yeah, you were talking about the dates functions, creating the
Okay,
date table, creating the date table.
yes. So I'm going to create the date table now. Probably that is where we'll probably stop from our end, and then you're able to ask questions and maybe practice what we've done so far. Um, so that's simple. I have to put it that way. But then something that you need to get familiar with and probably use from time to time that you're able to learn new stuff. You can't learn everything as you go. But as you encounter new cases and use more functions, get better. All right. So having described the reason why I have to create a date table, because I want to use time intelligence functions, right? I'm going to create a date table. So far we have seen you have seen me use new measure, new column. Now we are going to do a table, right? So the way I'm seeing this here, that is what we are going to see when I finish up creating a date table. And let me say it again. If you're going to create a date table, because there are different ways you can also do your date table, right? So because I'm going to use calculated columns, it is better that I do it in the source table for the reasons I mentioned earlier. Because additional columns, calculated columns as your data model, you want to avoid that. I think it's good practice, even if you're working with a small data set, so that by the time you get into working with data at the enterprise level, you're already used to it, right? Because at the enterprise level, every single thing that would impact performance is avoided, right? So if you have to add your dates, there are several ways. If you have an already um, established date table in your data source, maybe sitting in your SQL Server database, just put the data, right? Otherwise, if you don't have that, you can create your date table in Power Query, right? But since we are discussing DAX, right, I'm going to show us how to create a date table using DAX. Okay. So moving on, I'll click on this new table. So it comes out this way. So let me name it date. I can name it date table. And there are two functions here. So if I want to create a date table, means that I want to get I want to have a date range from so date to so date. So I could say from 1st of January 2022 to 31st of December 2022, the full year, right? And when we want to create date tables, there are two functions particularly that we look at. We have the calendar, right? So if you look at my intelligence as usual, I have these two. We have the calendar and the calendar auto. So we are going to see how these two work. First of all, I'm going to use calendar auto. So what calendar auto does, in fact, calendar auto just does the work for you, right? What calendar auto does is, so it has only one argument, which is fiscal year end month. And you can see that even that one argument is optional because it's in square brackets, right? Like I mentioned before, even that is optional. So what that means is that this function, actually, I can just open and close the bracket and I have what I need. So I have a date range. So you can see that this date range starts from 1st of January 2011. And how is he able to determine, or how is he able to note that um, the data I have in my table is actually captured in this range? So what happens is that once you use calendar auto, right? It runs through your data model. It captures your maximum date and your minimum date, and it ensures that these two dates are well captured in the range that it will provide. Why am I saying this? Because sometimes you might use calendar also and it gives you as far back as 1923, 19, yeah, what am I saying? Yeah, 1900, in fact. So what happens is that it covers all of the range you have in your table, your existing table, right? So if you say, let's check what we have in our date key. What is our maximum date here? Let's see. Let's sort in there. So already seen that the list date here is November 2013, and the maximum date here is 2014. So we have only 2 years here. Is that it? I guess so. Okay, there's 2011 too. So why am I not seeing that? Let's see. Let's say ascending. Okay, yeah. So I'm seeing 2011. Good. So 2011 to 2014, right? So it has given me a range. Going back to my date table, it's giving me a range that covers 2011 and 2014. Right? So that's what calendar also does for you. All right. But sometimes, personally, I prefer to use just a normal calendar. This works fine. This works fine, actually. You can proceed and create other columns out from this single date. But let's look at calendar and then we'll use calendar to complete our date table. So instead of calendar photo, I'm going to use just calendar. And what calendar has for us is this. It has 2 arguments. Those 2 arguments, it says, all right, so give me your start date, give me your end date. So you have to manually impute the date, right? And for you to write any date function here, right? For you to actually write a date function, if you want to write any dates at all, you need to start with the date function, which is this. Hmm? So you have noticed that in a function, I have another function inside of it. So I have the date function inside the calendar function. Let me take it again. I will cancel. I know this is, for some people, it might be like, okay, what did you do here? So remember, we are starting with calendar. And we are saying that calendar has only 2 arguments or 2 parameters, right? You can call it argument, you can call it parameter. So it has 2 parameters here, which is the start date and end date. Now, we want to write the start date. So I cannot just write 01 date 2011, right? It doesn't make sense. It will allow me to, let's try this out anyways. Let's try this out. Let's see what happens. Let's say 31st for let's say 2015. So let's see what happens. What happened? Did he add? So you see what is going on here. He actually did something, but this is not the desired result, right? What I was actually expecting him to do is to give me a range between 1st of January 2011 through 31st December 2015. But that's not what I expected, right? So back to what I was doing earlier. First argument is the start date. And for you to write any date, right, you need to start with the date function. And then I'll put my bracket again. Inside of the date function, it allows me to declare the year, the months, and then the day. So I'm going to do that. So I'm going to use, so because we have seen that data started from December 2011, right? So to be on the safe side, let's say 2011, comma, I'm going to do January, which is January is 1, right? And the day is 1. I'm going to close this. So once I close it, you can see that it's still highlighting my start date. So that means I've completed my start date. So all of what I've written is my start date. And then once I put on this comma, it's asking what is my end date. So the same way, I'll start with my dates. So I think our data ended in 2014, but let's, to be on the safe side, let's put it at 2015. Nothing, there's no harm in doing that. 2015, what is the month? For day 31st. So that means now I've completed my end date. And so I can close up everything. I click enter. And so now you can see there's a date range, which is what I require. So it gives me a date range between these two dates. So, but again, is this the best practice? Yes, this can fly if you're just working on a static data that you won't refresh tomorrow, or that you don't need to refresh. So imagine that this is data that changes over time. And let's say my data grows. So what happens if my data grows past 2015? What happens? It means that my analysis, it won't be captured because my date table does only stop at 2015. Right? So why we can run with this because of course our data sets, we're not going to refresh it. It's just going to be what it is. So we can do our analysis, everything is fine and good. But to be on the safe side and to make this dynamic, what we have actually done is to hard code these dates. Hard coding means that it's static. This is the start date, this is the end date. No matter what you do till tomorrow, we have hard coded this thing, it's going to remain the same. But if I want to make this dynamic such that if my data grows beyond 2015, the system will automatically capture it, right? So I'm going to start it all over again. Let me put this in the chat. Chat. So I'm going to start again. So using the same calendar. So it's asking me for my start dates. So I'm going to say, I'm going to calculate this with an existing column. Remember, we have a column that speaks to sales dates, right? Let's see. I have a column that says dates. No, yeah, dates key, right? Let me format this a little bit so that it's a format that we are familiar with. Day, month, and year. Good. So this is day, month, and year. So I have, this is 6th of December 2011. All right. So I can see that so we're going to be using this in creating we are going to be referencing this particular column, this date key column in our calendar function. So basically what we are saying here is, instead of hard coding this, what you can do for me is this. Why don't you give me the minimum date in my date key column? So I'll start with min. So remember that I talked about aggregation functions. What min does is it looks through your whatever column, right? If it's numerical, it looks for the minimum number. If it's the date column, it looks for the least date, right? If it's a categorical column, that means maybe a column in text. It sort of arranges it in alphabetical order and then gives you minimum will start with an A, yes, maximum will start with a Z, that way. So, but now we are dealing with a date table. So I'm saying, give me the minimum value in the date key column, right? So I've opened this. So once I open this, you will notice something here. It says, the part right, it has more than one argument, but the first argument is compulsory, the second is not. You can see it says column name or scalar. So when we talk about scalar, right, scalar is just a single variable. So if I say minimum of this date range, it's only going to return one value. And when you're returning a value, it's called, you're returning a scalar quantity. It's just one value, just one value, right? Max of something, max of a data range or a date range is just one value is going to return, right? Average is going to return one value. Want to sum is going to return one value, things like that. That's why they are called aggregation functions. So it sort of aggregates all of your data points and gives you one number to describe it. So what I'm trying to say is we are using minimum here, right? And it's saying it's going to return the minimum date in whatever column you specify here. So it says we can give it a column name or a scalar value. So, but here we are dealing with a column name, and the column name here is the date key, and the date key is in the sales details table. All right, I've lost my mouse. Can you still hear me? Okay.
Yeah. Manuel, loud and clear.
All right. So minimum in I'm looking for date key. Date key. Okay, this is it. So I'm saying my start date is give me the minimum value in this column. That's my start date. And then I give it a comma. What is my end date? I say give me the maximum date in that same sales in that same date key column. And once I'm done, I can close it up. So it gives me a date range, right? So in this way, I'm no longer hard coding the dates. This is not dynamic. So even if tomorrow we connect to a data source and it appears that 2011 is no longer the list year, it's as if we have data back as far back as 2005. Nothing changes. Minimum would look through that and grab the minimum date, and your life goes on. Nothing happens, right? Just gonna draw this. Yeah. Yeah. So I think I will stop here and probably, but there are some other things we'll have to do. But any questions so far, so that we don't get too lost. So far we've looked at some functions: if, calendar, minimum, maps. What else have we looked at? We looked at dates. Yeah, dates as a function as well. So any questions so far? Patrick, Kanayo, Lolade, was it?
What's going on? Have we slept off? Patrick, Lalade. Nobody is speaking.
I'm here. I'm here.
I'm here.
Kanayo.
Are we?
Are you
So we are
are you
saying.
following? Do you have questions?
So we are saying we are good.
No questions so far.
For now.
Are you following though?
Yeah, sure.
Yes.
Okay.
Okay. For
Okay.
now, you're good.
It's complicated, but you have to
No,
You see,
it's not complicated.
no, all you need to know is just take note. You don't need to cram it. Yes, they are just syntax. Very good. Yes, you need to write them down, then understand it. Yeah, that's why I said you should paste them, put them on the chart, so you can copy it and put in your notes, so you could look at it later. There are several syntax, so yeah, you get used to them. Don't cram anything. Just take your time. Yeah,
Yeah.
DAX. Yeah. Okay. Okay. Back to you, Manuel.
Yeah, so I wouldn't want you to come with the idea that it's complex. It's not really. It is not. So just take that off your mind, and maybe that would also help you understand, right? But I think this is recorded, so we can actually go back and look at it. So, so since there are no questions, I'll just proceed and possibly be able to rewatch and do some of the things we've done this evening. Yeah, you're saying something?
Yeah, I would like to rewatch it, so I will help you.
Okay. All right. So going forward, we have our date. So it gives me a date and time format. I mean, this time is not useful, and check it's just giving me 12 a.m., 12 a.m., 12 a.m. So I'm just going to remove this. See this date and time here. I'm going to change it to just date. Right, just date. So this is what I'm working with. So it's giving me dates and then not the right format. I'm just still going to come here. I mean, you can choose whatever format that suits you, but this is what I like to use. Day, month, year. All right, so we have our date range. Now we are going to use a couple of functions to extract the year, month, and the day, right? Possibly the quarter as well. Maybe the year, the quarter, the month. Let's stick with those ones first. If we have enough time, we can go into the weekdays, week number, and all of that. Right. So I've created my first column, which is the calendar function. I want to create a new column. I click on new column. And here I'm saying this is going to be a year. Simple, we have a function year. So this is quite easy. So year only takes a date, right? So we are going to reference our date column in our date table. So this column is what we are referencing. The date column in our date table. And voila, it gives me, it extracts only the year. So from here, I can clearly tell we have 1, 2, 3, 4 years. Quickly extracts only the year, right? I'm going to do the same thing for quarter. So for quarter, we also have a function called quarter. And in the same way, I'm going to reference the date column, right? So you see that I have numbers 1 to 4, which represents quarter 1, quarter 2, quarter 3, quarter 4. So quarter 1 would be January, February, March, right? Quarter 4 would be October, November, December, right? So you can see that all of these I have for they're either October, November, or December. So all of this is December. And here I have January, so it's first quarter. I have January here too, first quarter. So but then if you're going to use this in a visual, you want people to read it as quarter 4 or Q4, you know. So what I can achieve that by adding the letter Q to this. And how do I do that? How do I do that? Just, whenever you're writing a text, yeah, it has to be in a double quote, right? So I can say in double quote, give me a Q, and then concatenate it with whatever value that I have here, which is, so I'm going to use the ampersand, right? So I'm saying that whatever value you get here, whatever value that is here, please add the letter Q to this, and we are good. So I have Q4, Q4, Q1. So it's a bit readable now, right? And you can use it in your report, and people are able to quickly tell what the number is. Yep. Any questions from there? Someone is. Guys, are you there with us? You want to ask a question? Does you want to ask a question? All right. So moving.
No, I don't.
Oh, okay. All right. So moving forward. So if you feel you need a space here, if you feel you need a space between the Q and the 4, there are two ways you can do this. You can either do, let me go the longer route first and then show the shorter way. You can add Q and then you add, let's say, with ampersand, add a space here and this. So what I did was add Q, add a space here, and then add whatever value you have from this, right? And I have a space. Of course, I mean, I don't need this. I want them to be together. So instead of doing this, I could easily have just done this. I could easily have just added this space here, just Q inside the same quote, right? And I have the same result. Nothing changed. So you see the same result. But I don't need that space. So I'm going to close it. I have my Q4. So we have quarter. I'm going to do for month. Let's say new column. Same way, I'm going to do month. I'll reference the date table. Dates, the same date we've been referencing. And then again, we have numbers instead of December, we're having it as 12. So recall that is extracting the month in all of this. All right. So, but what if we don't want people to quickly visualize and look at your data and say, okay, this is January. You don't want them to start thinking, what is one? Is one quarter 1 or is it January? We want to eliminate that. And so what we're going to do is to use another function. So I'm going to call this month number. So the second one I'm going to create the month that has the text. I'll add new column. This new column, I'm going to call it the month, the normal month. And I'm going to introduce another function, which is not it's not in the it's not like the regular ones we've been seeing. So we've been seeing year, quarter, month. So now I'm going to deviate a little from that standard. We have a function called format. So what format has two required parameters? It has two required parameters and one optional. Right? So the first parameter here is the value, and then it asks you what format do you want your value to be in. And then you have your local name. This is not optional. So most of the times I don't even use this, right? So what is my value here? My value is still the same date we've been referencing. Can you hear me? It says I have bad network. Can anybody hear me?
Yeah, loud and clear.
Okay. So I'm still going to reference the same dates that we've been referencing before, the same date table, date in the date table. comma, and then ask me what is. So please, something happens here. Something happened here. Back again. So just so that when you're rewatching this, you're not confused. Immediately I put in this, you can see I have this couple of options that pop up. It gives me dot date, dot this, and all of that. So just ignore. What I did was just put a comma afterwards, right? And then goes over to the next, asking me what is the format. And my format here is, I want it to be JAN for January, FEB for February, right? So inside a double quote, I'm going to give it the format as MMM, right? Meaning give me, it's going to be a month, but then give me just 3 characters of that month, the first 3 characters of that month, right? And then I think I'm done here. I'll close my bracket and let's see what happens. So you see, it gives me my month as I want to. So if I add more, let's see what happens if I reduce, if I put it to one, just 2 M's, what happens? Let's see the different variations. So here it gives me 12 again. Let's see if I add one more to 3, so making it 4. Let's see what happens. What does it give me? It gives me the full name, right? So you can either decide to go with this. It depends on you and your report, how you want to visualize it. Or you can just leave it as 3. I prefer, I like to use 3, so I just leave it to 3. So here I can easily tell that 12 means December, right? What else am I missing? So we also have for week. Let's try that. Let's see what that gives us. Let's say new column. New column. We'll say week. So we also have a function called weekday and weekday norm. We're going to explore this. So I think this is where we close up for tonight. So if I say weekday, it's important that you pay attention to the arguments that cause it. Sorry, this thing keeps happening. I keep pressing the wrong key. Okay. So I have my date. What is my date and what is the type? You see that thing. So you can see the type here is optional as well. Date. So all of these have what they signify. Listen, let's go with one. So weekday. Okay. So it said returns the number from 1 to 7, identifying the day of the week of the date. Yeah. Any question? Someone is trying to say something. Okay. So let me see if I can have the latest date here. I'm trying to see what is. I'm going to copy this. Let me see what time of day that is. Whoa, I just copied something, just one. Let me see. Okay, I'm just going to type it. I want to see what date that is. 0612 1106. What day was it? It was a Tuesday. It was a Tuesday. Good. So it was a Tuesday. So That means when we clicked on one here, it started actually counting from Sunday. So we have Sunday as the first day, Monday as the second day, Tuesday as the third day. Now let's change this to 2 and let's see where it starts counting from. So it's not counting Tuesday as 2. So you're seeing the difference. So because of it depends on where you're working this from. Some people start their day, maybe those in Saudi Arabia, or start their day from Sunday. So Sunday will be the first working day of the week, right? So if you're in that environment, you need to specify that the first working day of the week is one. So it allows you that flexibility. So, but in Nigeria, or maybe in most, maybe Europe or most parts, first working day is Monday, right? And so you have to include 2 so that Monday will be first day and Tuesday will be second day, just like you're seeing here. So that means if I'm seeing 7 here, 7 means Sunday instead of 1, right? So we've seen for week. So this is actually week number. Let me see. Let's quickly create the last week and call it a 9. So we have week 8. No. Oh, I was using same weekday. No, sorry. Now I want to use week number 2. Um, 8. So this actually returns weekday. So we have how many weeks in a year? 3, 4 weeks, right? So this gives us a different number altogether. So you can see this is the 50th week in the year. This is the 50th, the 51, the 52, the second, the third week, and this is the first week. First week of the year, you can see is January. January is the first week. So I think I will stop here for the night. Depends on what kind of analysis you're doing that you add all of this, right? So I'll stop here and probably take questions and call it a night. Please always remember to save your file. It's important. Very key. Very key. Let me see. Any question? Franca?
Yeah.
All right, so no
Okay.
question. You can, I'm done for the night. Yep.
Okay. All right. Thank you, Emmanuel. No questions, Patrick, Lolade. Not to worry. Dax is. I'm sure if you're used to Excel, you know all the syntax you have. You can always check on them. So, and you don't need to cram anything. So once it's a good thing. Like just take notes of the formula, the syntax, and you can always go back to them. Yeah. So that's DAX for you. Okay. In the absence of any questions, please practice. Yeah, from what we've done so far. Yeah, have you been practicing? Have you been trying them out on your own? Patrick? Anyway, the good thing is, Patrick, you've been having hands-on, which is good. Yesterday you were complaining that it's only you sharing your screen. You should be happy that you're having hands-on. Yeah, because that way you practice and you don't forget. Yeah. Okay, Lolade, okay, I hope you'll be able to set up your new system for tomorrow. Just download your Teams. Okay. So in the absence of any other questions, please feel free to drop your questions also on the WhatsApp platform. Yeah, drop your questions if you're working during the day and you have questions. Okay, in the absence of any questions for now, we'll call it a night. I will see you tomorrow evening by 8. Please endeavor to come in early. Okay, good night, everyone. And have a good night rest.
Good. Thank you.
Good night. Well
Good
done.
night.
Thank
Good
you.
night. Thank you.
Good night.
Thank
You're
you.
Right. Good
welcome.
night.
Thank
Good
her.
night. Okay, good night.
Good night.
Olive, good night. Emmanuel, good night. Joan, Lolade, good night. Ngozi. Have a good night rest and see you tomorrow.
Okay, thank you.
All right then.